Hey MD, can you hear me? Hello. Hi Zubair. Hi Emily. Can you hear me? Zubair, can you hear me? Yes, I was able to hear you for a sec, but I think Emily, there's some issue with your mic or something. But I can hear you with some hiccups in between. So hope Zubair and Emily, you were able to get the access of the videos. You were able to watch the videos. Any questions on those?
So it says the Gmail email works.
Yeah. So actually, YouTube allows as a Gmail proprietary. So YouTube allows Gmail only. So that was the issue. Cool. So any questions which you have by the time other people are joining in on the recorded session which you people watched?
Other questions? No, I'm good.
Okay, that's good.
I have a question, sir. I was trying to, after the installation of the, what's that? Give me 1 second. Of the Oracle VirtualBox, and then I installed the Sandbox, but I was not able to access to it, sir.
Oh, what is the error you are getting?
1 second, let me read out the error for you. And once I right click and click start, the error it shows is failed to open the session for virtual machine Hortonworks Sandbox 2.1.
But it okay failed to open, but it would be giving some other error also. See, some error would be coming, either virtualization disabled or 32-bit, 42, 62-bit, 64-bit kind of thing, or something which would be coming.
I don't know, sir. Do you want me to share the screen?
Right now, I don't want to share the screen. So, okay, can you read the whole error? What you are getting? Is this the only line or something else also comes?
The first line is failed to open virtual machine. Then it says V2 Hacking X is disabled in the BIOS.
Yeah, that is what I know. Something is there. So actually, now go to the installation document. There is installation document lying over there. Your virtualization is disabled, right? This is the error which you are getting, right? It's saying virtualization is disabled, right?
Hello, yes, sir.
So actually for virtualization, what you have to do is go to this thing. There is an installation document lying in the same folder from where you downloaded this Oracle VM and the OVA file. There's an installation document lying over there that talks about how to enable virtualization in your BIOS.
Okay.
So there's a software also which is shared which will tell you whether the BIOS is disabled, whether the virtualization is supported by a motherboard or not, and if supported, whether it's disabled in your BIOS or not. So if you are having ages old laptop, then it might not be that your motherboard might not be supporting virtualization. But if your laptop is 4 or 5 years old only, so in that case the virtualization would be supported but might be disabled. So just look into the document. That document will talk about how to enable the virtualization in your laptop. For that you have to reboot your laptop also and go to the BIOS settings to change it. And there's one software also which I am talking about in the document, which is also shared in the Google Share Drive only. So that software will tell you whether the BIOS virtualization is disabled or enabled. Okay.
Thank you.
We are waiting for others also to join in. Looks like no one has joined till now. We'll wait for 5 more minutes, otherwise we'll start. So I think let's start. People might be joining in later on. They can keep on joining. Let's start, and people can join in later on. So I hope you people are clear with the MapReduce part now, and you understand just the flow of MapReduce. I'm not worried about if you know the Java part of the MapReduce or not. But all I want to know is you understand there's something called mapper, there's something called reducer, and how the whole data flow happens, how the key and value pairs are created, and how those flows to make or to really process your data. And based on that, we'll be understanding the Hive. So Hive was developed at Facebook, used for majority of Facebook jobs. Most of the Facebook jobs are running on Hive. And Hive gives you a relational kind of database structure on your HDFS file system. So basically it maintains list of table schemas. It gives you SQL kind of query language, what we call HQL, Hive query language. It supports tables, partitioning, clustering, complex data types, and we can do a lot of optimizations also. How to run the queries. We can also look into the execution plan of the queries. We can do n number of things in Hive. All we have to do is just define a table kind of structure on top of our unstructured or semi-structured or structured data, and then with the help of HiveQL, that is Hive query language, we can access the data or we can process the data. Okay, so why another data warehousing system? So the problem with your traditional data warehousing systems or problem with the traditional, SQL kind of systems is nowadays we are sitting up with terabytes and petabytes and zettabytes of data. And there's a limit of vertical scaling what we can do on our traditional systems. Moreover, they are not scalable enough to handle your terabytes or petabytes of data. I hope you would have worked on the Oracle part, or I would not name any traditional database system rather. So I would say you would have worked on them, and you would have seen when the table size grows, you have to index your tables, you have to optimize your take queries and do things like that to get down the output, and your queries might run and run and run too, and you would be waiting on for the outputs. So till a particular extent, your traditional data warehouse systems are good enough, but as the data increases beyond their limits, these systems become bottleneck to process your data. And that's the reason people like the Facebook came up with something called Hive. So it gives you a query line of SQL kind of language to process your data. How? We'll just look into that. So the Hadoop experiment uses Hadoop file system and it's scalable. So as it runs on HDFS part, it's pretty much scalable and high availability, as you can understand why the HDFS file system is high available. The problem with your MapReduce part was they had a high development lifecycle. You should be knowing Java. You have to create your Java code. You have to create the ZAR, deploy the ZAR, or put the ZAR into your HDFS word and trigger the ZAR. So there is a learning curve also involved, and the kind of Java code which was required to process your data was enormous. So the solution with which Facebook came was Hive, what is called Hive. So what Hive does is you write your SQL kind of queries, and at the back end it will generate a MapReduce code for you. So you don't have to worry about what is the MapReduce code I have to write to join two tables or to join two different unstructured data. I don't have to worry about what kind of data is lying in my system. All I have to do is just define a metadata on top of my data which is lying in my HDFS system, and I can very easily look into the data, process the data with the help of query kind of language. Hey Vikram, welcome. So I was saying you have to just write a query kind of language, and at the back end it will generate a MapReduce code for you. And the storage which is used is your HDFS storage. So it inherits all the features of HDFS. It inherits all the features of data processing from MapReduce. And as a front end or as a language, it gives you SQL kind of language. So the learning curve is very less. Moreover, you get the high availability kind of systems, and all your data flows with the help of in the MapReduce flow. So all your system could be scaled as large as possible. So I hope you remember the Java code which we wrote for word count example that had, I think, 65 to 70 lines of code to write to do the word count. But this could be achieved in just 3 lines of code in Hive. So don't worry about the complexities of these words. We'll talk about them, but just try to understand them. So here what I'm doing is I'm creating a table called doc on my file which is lying in the HDFS system, and I'm saying some and I'm saying some of them are basically the delimiter of the fields is and the lines that are measured by slash. And I'll talk about all these things later on. And the file is stored as text file. So this is a file which is lying in my SDFS file system, and I'm just creating a metadata on top of file. Hey Jignesh, welcome. So we are just creating a metadata on top of file, and with the help of the metadata, we are trying to process or look into the data of the file. And then we are just importing that data, what was there in my file in my SDFS into this table. I could have created a file directly on this table. We'll talk about all these things. And then I'm just selecting data from that table and doing count by splitting the text by a space and grouping by the word and just doing the count. So it will basically group your all words and produce the count of the words. So this is a 3-line code which will produce your output what was done by the MapReduce word. So for Vikram and Jignesh who just joined up, we were just discussing about Hive. I'll quickly recap in a minute what we were discussing for your benefit. So what I was saying is Hive is a query kind of language which helps you to process your data which is lying in SDFS with the help of SQL kind of language. So Hive has HQL, Hive query language, by which we can process the data. The data could be unstructured, data could be semi-structured, data could be structured. We can process the data with the help of Hive query language. And the benefit which we get is the benefit of SDFS and the MapReduce, what they gave to us, high availability and horizontal scaling kind of architecture. So at the front end, we have to just write a query kind of language like this, and we can process the data. So this code will at the back end will generate the same MapReduce code what we have created in Java word, but we don't have to worry about all those complexities. We have to just write these 3 lines, and we can produce a word count of our file. Let's try to run it before going ahead, and then we'll talk about the kind of data types and all those things, how the query will look like. So give me a minute. Let me just switch over to VM and let me show you this. So I hope you can see my screen, and to go to Hive console, all you have to do is just type Hive and you can go to the Hive console. So I'll just go over there, but before that just give me a minute. Okay. So I've just typed Hive and it will take me to the Hive console. So when I type Hive, you can see at the bottom of the screen, I can see the Hive console. So I'll show you all the commands which I'm right now typing, but I'll just show you how quick we can do the word count example with the help of simple 2 or 3 line of commands. So I'll just cross check if there's a table. Okay. So let me just so the table already exists. I'll drop the table before that. So I've just created a table and we'll import the data into the table. So before that, I'll just look into any file which is lying with a text by kind of a structure, and I'll just import that file. So I'll just cross check into the SGP system if there's any file lying which has a kind of text. I don't have anything like a text, So what I'll do is I'll just create a file quickly and give that as an input to this command. So I'll go into the file browser, and here I can create a file very easily. I have to just say new file and give it a text.txt and submit it, and we'll just type few words and we'll try to text.txt, and I'll just say added file. I am So I've just written few text over here, and we'll give this file as an input to our file. So the file name was text.txt, and so I'll just import that file and sorry. So I'm just loading the data into this table. How that is done, we will look all these things in detail. Don't worry about that. Sorry for this. You might be seeing some beautiful flowers. So I forgot to disable this while starting the session. So this is just a reminder for me. It keeps on popping after 15-20 minutes, which reminds me to blink my eyes. So I just forgot to disable it prior to the session. So it will be there for a minute. Just wait for a minute. So what I'm doing is I just created a metadata which is defining a type of table, and table has only one column, what we called table name was doc, and table column name was text. And now I am just pointing the table to a data, or basically I'm loading the data into the table, and after that we'll just run the query to select the words, different words in the file, and we are just splitting the text in the file by a space, and will produce the output. So I'll just disable this guy so that it does not prompt again, and now we'll just do the count of words from this table by the help of this table. So at the back end, you can see that it is doing the same thing. It has created the map and reducer for us, and it is trying to do. So it says this is the tracking URL by where I can track this. It has created a jar at the back end, submitted that jar. The job is there. The job ID is this, and now we can track this process. It will run all of the MapReduce code for us at the back end, and we don't have to worry about anything. All we have to do is just write a simple SQL kind of language. So see, it has created, it has done the mapper part, it's just doing the reducer part, and once the reducer is done, it will. So see, it has produced the output, and it has written all the words and their corresponding count. So what we have done in 60-70 lines of code in MapReduce could be done in just 1 or 2 line in Hive. We'll look about the details and complexities of this query which we have just ran, but I just wanted to show you how easy it is to write a program or a code or HQL with the help of Hive, and get the outputs, desired outputs. Okay, so anyone has anything to ask before I go ahead? Okay, let's go ahead. So as any other language has, it also has the primitive data types, and it also supports a little bit complex data types. By primitive, I mean to say it has all your integers, begin kind of thing. It has Boolean, it has floats, doubles, strings, and timestamp. So all your primitive data types are supported over here. And in the latest version, 1.3 date is also there. Right now we are running 0.12. In Hortonworks 2.2 sandbox, we have 0.13, and that supports Redis 5 also. But here we have a timestamp which will work similarly for you what date is doing. That is not having just a timestamp part of the date. Other than the primitive data types, it also supports the complex data types which are not supported by traditional data warehousing systems, and this makes Hive a wonderful choice over your traditional data warehouse systems. So we can have something like structs, we can have maps, we can have arrays, which are now supported by any of the traditional data warehouse systems. So I hope everyone understands the structs, map, and arrays. Okay, I'll just assume everyone understand it. So tables, we can create a table over here as I've just shown you. This is similar to database tables, DB's tables. Each table is corresponding to a directory in SDFS. So at the backend, data is lying as a similar fashion as we put in SDFS. So here, if you can see, I've just created a file in SDFS with the help of UI, and I've just loaded that file into the table. We can directly point the table to that file also. I'll show you all these things. So your data is there in your SDFS. Hive just create a metadata on top of data, and that data is stored in hcatalog. If you have seen the UI, there's something called hcat symbol. So that is hcatalog, which really stores all the metadata of Hive, and that hcatalog can be shared with different technologies also. Like Epic can query hcatalog to find out the metadata for a table of Hive and can process the data. So a beauty of the whole system is your data is lying in SDFS only. These are the different technologies which help you to process the data, and these technologies are just maintaining their metadata, and when we give or fire any command, we just fire those commands on the metadata, and based on the metadata, your MapReduce code is generated, and that do the real processing into an SDFS world. So here that file was lying in SDFS, and we just triggered a query, which query was nothing, the kind of MapReduce program at the backend which will be written by the BigQuery, and that process the data. So here, for example, if I say table design Pathshala could hold the data inside SDFS directory, and the directory could be /com/design Pathshala. So there could be n number of files inside this directory, and all I say is this directory is pointed as design Pathshala table. So all the files inside this directory would be read by this table design Pathshala, and we can just give the structure of the table, how is the structure of our data inside this directory. So anyone has anything, or Jignesh said yes. Okay. Okay, sorry, Jignesh, I did not read a question. Okay, so any SDFS data that we need to use with SQL needs to be imported in Hive table first. Now, Jignesh, we don't have to import into the Hive table for Hive table. We can directly point the Hive table to that data, and the metadata would be created for you, and you have to just write the SQL to process the data. How that is done, we'll look into all those things pretty soon. You don't have to import any data into Hive. Hive does not store any of your data. Hive, all your data is there in SDFS only. Hive is just a language which helps you to process the data. So when I say create a table, I am just creating a metadata of the table which is stored in hcatalog practically, and your data is really lying in your SDFS files only. So when I imported the data, I just copied the data in from one location to another location into my SGFS file system in the previous command. And why I did that is just an example to show you how that happens. But when we'll go deeper into this thing, you'll get to understand we don't have to import any data. That was just example which I showed you. Okay, so Jignesh says okay. So this is a normal table, create table command looks like in Hive. Just try to read this, and if you can understand this create table, you are good enough with Hive, and the rest all is the normal SQL queries. So here I'm saying create table, table name, design Pathshala employees. Name is a column, salary is a column, subordinate is a column, deduction is a column, address is a column. This is of type string, float, array. I've used all the complex data types over here. Map and struct. So struct is composed of street, city, state, and zip. So this is a full address. Comment is nothing. We can give a comment to a table so that later on if we want to know what kind of table it is, so or what is stored in this table kind of things. So we can. So this comment is not a correct one over here. Partition by, we'll look into this thing later on, but those of you who are from database background, I hope you understand what is partition by, but we'll look into this later on in detail. Then row format delimited. So this is the real beauty of this table, which tells about how the data at the backend is there and how to extract out columns from your data. So here I'm saying fields are terminated by /001, collections are terminated by /002, and maps are terminated by /03, and lines are terminated by /n. So line is a new row in the file. So all of this is separated by /n. Fields are terminated by /001. So after name there will be /001. Then after salary there will be /001, and so on. Collection items. So by collection I mean to just say arrays or in between the structs. So collection items are terminated by /002, and map keys, key and value pair, are terminated by /003. And this at the backend is stored as a normal text file. So /001 is nothing but in your computer language or from the keyboard perspective it is Control A, and /002 is nothing but is Control B, and /003 is nothing, it's Control C. So when you press Control A, it's practically the code which is generated is kind of /001, 2 and 3 ASCII values or something whatsoever we want to say. So let's look into the data which will be read by this table and how the table is created. So data is something like this. We have, I hope you can see the different colors of Control A, Control B, and Control C in this data. Control A is a brown color character, Control B is a green color character, and Control C is a kind of pinkish character. So file starts with name. So the first thing is name John Doe. Second thing is the salary, float. Second thing is the salary. Again, both of them are separated by Control A because our fields were terminated by Control A. Then the third thing is Mary Smith. So Mary Smith is his subordinate. So he or she has only one subordinate, or no, more than one. So see, this is the whole field which is from here to here. So here is the field ends. And in between the collections are terminated by Control B. So the two values or his two subordinates are separated by Control B. And then we have a map of deduction. So he has a federal tax of 0.2%, state tax of 0.5%, and insurance of 0.1%. So you can see the map keys and values are separated by Control C. This is one pair of data in the map. This is separated by Control B, and this whole field is separated by Control A, and so on. And I probably the /n are just missing over here, but if I copy this data to Notepad, /n will also be visible. So the /n is not visible, but after this address, this is okay. So this is a /n over here. So practically this is new line, and again a new line somewhere over here, and so 1 record, 2 record, and 3 record, and so on. So practically this is how the records of the backend are lying in my unstructured or structured or semi-structured kind of file. And all I have to do is just write this create table command. So with the help of this create table command, I will get to know how is your data in your is there, how to divide the data, how to name that data to different columns. And once I understand that, all you have to do is just select and where kind of things. So anything over here? Any questions? Are you able to get this point? Jignesh says yes. Pawan, Vikram, Zubair, Emily. Pawan also said yes. Okay, Vikram also said yes. So Zubair also said yes. Okay, so I'll just assume yes for Emily also. So this table could have been in the JSON also, like this. I hope everyone understand JSON. If you don't understand, do let me know. So here, name, salary, subordinate, direction. The same type of structure could be used to load the data. All you have to do is just change these fields. How my data is lying at the back end, I have to just tell him JSON format. Okay, Pawan says what is no, I don't know what is JSON. Okay, Pawan. I'll just come to you. Just give me a minute. So if the data, so Pawan, if right now the data file was something like this, if the data file was not like this, my data file was something like this, same structure or same create table would have worked on this. Only the thing which required to be changed was this thing. We have to just tell how our data is separated. So here we could have given a Saturday. Saturday is nothing but serializer and deserializer. I have talked about serialization in the MapReduce part, but if you just forgot do ping me. So we have to just say the serializer and deserializer over here, and we could have read the same file if the data is stored in a separate structure. So Pawan, I hope you understand the XML. XML is, I hope you understand XML. JSON is a lighter version of XML, you can say. It's used highly in the industry to transfer your data. And the beauty about JSON is it not only stores your data, but it also stores the metadata of the data. That is, so here this is name and the corresponding name, salary and the corresponding salary, and so on. So the beauty of the JSON over XML is it is a lighter version of XML. By lighter version, I mean to say, if you know XML tags start something like this and something like this /name. So the name is repeated twice, salary is repeated twice, and so on. So XML are heavy as compared to JSON. JSON is a kind of lighter version of over XML, and this is highly used in the industry to transfer your data across different parties. Hey Pradeep, welcome. So
hey, I'm sorry I'm late.
No issues.
I got held up somewhere. I'm sorry.
No issues. So we just started about Hive, and not just we started around 30-35 minutes back around 5. So wherever you don't understand, do ping me, and in the interest of time, I'll not repeat the thing. But wherever you don't understand, do let me know, and otherwise later on you can just watch the recording also.
Okay, thank you.
Sure. Okay. So Pradeep, just to make you in line with the class, I'll just tell one thing, that we are talking about Hive. Hive is a kind of SQL or query line of language which helps you to process your data lying into your SDFL. So all you have to do is create a metadata on top of your data. You never touch your data with the Hive. Hive just have your metadata, and you just create a metadata on top of your data, and you play with the metadata. You write a query like this thing what I've shown on the screen. So this is by this query, I'm reading the LGFS file. The LGFS file might be like this, might be like this. I'm reading this file. I've just defined the metadata, and later on, I'll write a query to process this table. So Hive will generate a MapReduce score for me and process the data. So that is a sweet short of what we discussed in last 40 minutes.
Okay, thank you.
Sure. So I hope, Pawan, I answered your question. JSON is what is JSON, and what I was talking over here. We'll look into what is Saturday and how the Saturday could be used to read the JSON format in the Hive. So any one of you who is not familiar with the SQL kind of work, so if any one of you is not familiar, I'll go deeper into all these things, database, tables, and all those things. But if you are familiar with the databases and things like that, I can just touch base on these things, and we can proceed at a little faster pace. So if anyone of you don't understand table, database, queries, query clause kind of things, so ping me right away. I'll go at that phase then. Okay. So I'm just assuming everyone understand the SQL kind of language. So Pradeep, I'm just muting you, and you can just ping me on the chat window. Sure, thanks. So so as similar to any SQL word, you can create database in Hive. So create database name. So here create database design Pathshala will create a database by the name of design Pathshala. Create database if not exist. Basically, if the database not exist, it will create a database by the name of design Pathshala. Show databases will show you all the databases in your metadata. Show databases like the star will show you all the databases starting with D. So the default location at where your databases are created is app hive warehouse database name.db. This is the default location in the LGFS where your database will be created. I'll show you how to get this location also. Everything is configurable in this word. I'll show you how to get this location also. This is there in your Hive configuration file. So it's stored at by a parameter called hive meta store warehouse.dir. Create database design Pathshala location. I can give my location also where to create my database if I don't want it to be created at this default location. What is defined in my warehouse directory in the metadata of in the configuration parameters of Hive. Create database design Pathshala comment, and I can hold the comment also while creating it. So it will just a future reference kind of thing. So let me, okay, before this, let's talk about this slide, and then I'll go back to the Hive console. Describe database will just describe your database, the properties of the database. Describe database extended will give you furthermore little bit more properties of a database if we have set comments like this or the new location kind of thing and all those things. And Hive CLI print current DB equals to 2, so this will always print your current DB on your Hive console. And drop database, I hope everyone understand, drop will drop your database. So let me go back to the Hive console and show you these things in a quickly, and let's move on to the next topic. So give me a minute. So if you remember, I have said here use DP. So DP is the design Pathshala database which I have created. I have just said use DP. So now I am inside the design Pathshala DP database. I can create database by any name, say Hive test and press enter. So this will create a database. I have not given any location, so this will be created at a default location. If we don't know the default location, all we have to do is just look at the Hive parameter. So how to look at the Hive parameter is just set and the parameter name, and I don't remember the parameter name, so I'll just quickly copy it from the slide. So the parameter name is something like this, and if you don't remember the parameter name, I'll tell you how to get that. So for people like me, I never remember these things. So see, it has the default location which is set over here is Hive, apps, Hive, and warehouse. Let's go to this location and see if the database is created for us or not. So, oops, sorry. So what I'll do is I'll go to that location. So here there are a lot of files, but probably the database which I've created right away would also be there. The folder for that would have been created. What was the name I gave? What Hive test? Hive test.db. So the database folder is created. Now all the tables which I'll be creating will be for this database would be created by default inside this folder. A table could be associated to this database. However, the folder is not mandatory to be inside this database. It could be lying somewhere else also. But if you don't define them, the default location for all the tables for this database would be inside this folder. So Hive will just create your metadata, will not be touching your files unless your tables are internal table. What is internal table? I'll talk about that. So similarly, if I go over there, I was showing you how to get that thing, right? So let me quit from here. And all I have to say is Hive minus, what is Hive minus E? I'll tell you all these things. So I know warehouse is a place where Hive stores the Hive. Basically, your property has something called warehouse or dir kind of thing. So what I'm saying is I'm getting all the parameters of Hive printed on the console, and from them I'm just grabbing the parameter which have warehouse. So here I'll only get those parameters which have warehouse from this from all the parameters which Hive supports. So see, there are only two parameters which have warehouse. So if I don't know the whole property name, I can still get the app/Hive/warehouse is the location where Hive really stores its all the warehouse, that is the database. So there are different ways to run Hive command. One is going to the Hive console by Hive and by typing Hive and go press enter. The another way is to run the query directly as Hive minus E. And if you have the queries written in your file, you can use Hive minus app. I'll use all these things as we go in the session, and that will be more clear to you. And here I can say describe Hive, what was the database name? Show. So it will show me all the databases. Describe Hive test, and it will just say me, sorry, describe. So it also gave me where the location of my database and different things about the. I can use define extended also, but here it will not give anything extra because I have not defined any other parameter for this database. But that will be useful when we'll be talking about the tables. So let me go back to the PPT. And so this is how you can play with the databases in the Hive. After that, we have just looked into the tables. So similar to any other SQL command, if not exists also is applicable with your table also. Create table if not exists. So here my DB name.employee. So the table would be created inside this DB. And same what we discussed in the previous example. I'm just creating a table by that name only. Name, salary, subordinate directions, and comment, and table properties. I'm just giving some table properties also. So creator is design Pathshala, created at so and so date. Location, I'm defining location explicitly in this table. So this table would be pointing to this directory into your SDFS. So all the files in this directory would be read by this table, and this table is assuming your files are in this structure. And here, if you remember in the previous command, I gave something like this: rows terminated by, fields terminated by, collections terminated by, lines terminated by. So these are by default. If you don't define the terminated by kind of things like this, these are the default which Hive assume for you. So, and it's same to your MapReduce word also, but here no key value where lines, so there's nothing like tab, but the lines are terminated by /n only. So new records or new rows are terminated by /n only by default, and your fields, collections, and maps are terminated by Control A, Control B, and Control C in Hive. So as here I have not defined anything as a separator for my fields, these default will be taken care, and Hive will be assuming the data lying in the directory is inside is like this structure, or it's corresponding to this structure. We can change the terminated by to comma also. We can change the terminated by to anything which we wish, but by default these are the things: Control A, Control B, and Control C, and new line for the new record. So create table if not exist, I hope you know, and I am giving like another table. So it's all the commands are very much similar to your MySQL. Most of I need all of the commands are totally similar to your MySQL. So here I'm creating a table like this table, which is lying, which is by the name of employees. So employee 2 would be created, would have similar structure or metadata as this table. Show tables will show you all the tables inside your DB. Show tables in my DB. Here I am explicitly saying for inside which DB I have to see. Here I am saying show table, so it will show you into the DB which you have logged in. If you are not logged into the DB, the default it would be by default is a default DB inside which you would be there. Show tables by DESI star will show you all the tables starting with DESI. Describe my table will describe your table and show you the table properties, and describe extended my table will basically show you the extended my table properties. I'll just quickly show you one or two of these commands. So here use DP. Before that, I'll just drop this database which you have created. Use DP. So I have logged into a design personal database. Show tables. So these are the different tables. If I say describe table, say JSON table.
Viraj, what is use DP?
I'm just switching over to the database. Yes, Pawan, the DB always by default created inside your app Hive warehouse, but this property is configurable into your Hive properties as I just shown you. You can set the property over here like set. The property name, what was the property name? I forgot again. I don't remember those things. This thing, and is equals to whatsoever we want to give, and press enter. So this will be set it for your this session. If you want to permanently set it, then you have to go and change the properties from the Ambari UI, or you can go to each and every node and change the property wherever your Hive clients are running. So let's say EST describe table not found. No, I think okay. There's a problem with the Saturday. Okay, Saturday is not there. So let's not talk about this table. I'll talk about what is Saturday, how that is loaded. Describe any other table. So see, this table has so and so columns. This table is partitioned by date. And if I say describe extended, it will give me further more information about the table rather than only these columns and partition by thing. It also give me other things about the table. So here, if you can see, it talks me about the table name, database, owner, created time, last access time, lot of things it will talk about my table. It will talk about the location at which my table data is lying. The input format, I hope now everyone understands the input format, output format. So now everything but what we're talking about in MapReduce, if you remember all those things, you can easily correlate all of these things. Text input format is the default input format, text output format is the default output format. The compressions by default is false, number of buckets is not there. There could be bucketed tables. We'll talk about that. Serialization, deserialization, everything. If you can recall your MapReduce word, what we discussed till now, you can be pretty easily relate all of these things over here. So there are two types of table: managed tables and external tables. We'll talk about those things in little time. So managed tables or internal table. So there are two kind of table I was showing you, telling you on the console. So managed table or internal tables are the tables when basically when we create the tables, we don't define the location for the tables. And if you don't define the location for the table, by default the table is created into your the configured thing, that is your warehouse, inside your warehouse database folder, inside your database folder basically. So tables are in default created by default in a warehouse directory inside your database. And when we drop the table, there's an important thing. Please mind it. When we drop the internal or managed tables, it deletes your data in the table. So if we have not defined the location for a table and we have created a table, that table, although Hive only maintains a metadata, but that data database directory is also created by your Hive only. So I have assumed that you are using the table for some processing, and if you are dropping that table, you are not worried about the process data also. So Hive deletes the data lying in behind that table, and if you are dealing with the internal table. But if we create an external table, while creating an external table, we explicitly point to a SDFS directory. And when we point a metadata to explicitly SDFS directory, Hive assume that the data lying in and that SDFS directory is not no way proprietary of Hive, and Hive cannot delete the data. So when you delete or drop your external tables, Hive will not delete your data lying into your external basically in your SDFS directory on which this external table is pointing to. So this is a major difference between your external and internal tables. Both tables will look similar. There will be no difference how you'll be accessing these tables. Only the difference is internal table by default will be created into your default database directory or your default warehouse directory. External tables, you will explicitly giving the path where to create this table, and when you drop those tables, the data line or data in that folder or the files in that data that the directory would not be deleted by the Hive, because that are your files, and Hive should not be. I have only placed with the metadata. Pawan also said, sorry Pawan, I think I missed your question. The DB always by default gets created in app Hive warehouse. Yes, Pawan, I think I answered that. Okay. Any questions over here to external and internal tables? I'll show you quickly how these tables structure a little bit differs. But any questions over here?
Vikram here. So when when you say drop of the internal table, right? When we say all the storage is dropped or the files are removed, does it mean the warehouse is also
no warehouse
along with it?
No, warehouse, when you create a table, internal table, the new folder would be created inside your warehouse by the name of that table, and all your data would be stored inside that folder. So whenever we are talking about a table would be always pointing to some directory in your SDFS. So that directory will be represented by the metadata called table in Hive. And when we are playing with that table, we are really playing with the data inside the directory in your SDFS. And when I say drop table, I am definitely dropping the metadata which is lying in your H catalog, but on top of that, I might be dropping or deleting the data in SDFS only in the case of internal tables. And why that is data, I hope you understand, because internal table was created by the Hive, and when the internal table was created, there were practically no files or no data. And when you later on you process the data and inserted some data into that table, and when you are dropping that table, Hive is really dropping the data also, because that data was created by the Hive user only.
Okay. No, I was actually thinking of a scenario where the warehouse directory and the table directory are the same.
Oh, no. You might create it, it will not give you an error, but practically then you are just playing with the structure. Practically it will not never give you an error. It's just the metadata which is maintained. So even if you point the directory to a table, the table would be created. And when you drop it, the whole warehouse directory would also be deleted, but in that case you are just losing your data. If you're pointing it explicitly to warehouse, then you are creating an external table. So your data would not be deleted, or your directory would not be deleted.
Okay. And is there any way to tell how whether the table is internal or external?
Yeah. I will. We'll just we'll talk about that. Just wait a minute. We'll talk about it. So see in the previous tables, if you can see, I am just saying create table. I just said create table, and here I am saying create external table, and I am also giving the location where that table would be pointing to. So here this is an external table, and this table is pointing to data lying at this particular directory. And I am also saying row format delimited, fields separated by comma. So I know this is a comma separated file lying in this directory, and I'm creating a table on top of that. So let's look into this, create this and see. Give me a minute, let me show you the file, and then we'll create it. So I'll quickly switch over to the Hue console. So So this is the location at which my DP database is pointing to. While creating the database, I've given this location. And let's say some comma separated file stocks. Is this a comma separated file? Yeah. So this is a comma separated file, and see, this file has stock name, open price, close price, average price, cost, 3 or 4 different type of price, volume, and the date, the trade date. So this is a stock trade data, and I go back to the PPT again to show you what we were discussing. So here I have the symbol, that is a stock name, the open price, high price, low, close, and volume, and trade date. So, and the fields are terminated by comma. I have said over here, I have not said about the rows terminated by, so the default one would be taken care of, that is /n. And so each record or each row in this file would be a row in my table. So let's create this table and see. So I'll just copy it rather than creating it over there, and I'll just change the location. So I'll switch back to the Hue console. So it will give me an error. I'll just change few thing over there. So actually, if you have tab separators over here and we just copy it directly, I was not able to recognize those things and give errors for jump characters. So I'll just remove those tabs over there, and I'll just give the location. So I'll copy the location quickly for you. So if you see, I'm just giving it to the folder stocks. I'm not giving it beyond that, and I'll say just create external table if not exist, and so on. So now let's see, select start from stocks, and all the data is there for me, which was lying in that folder. And I can say where, what are the column names? Symbol is equals to rel. So now see, it has created a MapReduce program for me because now it has to do some data processing. Prior to that, I was just looking into the file. It did not require any data processing. It just required Hadoop FS commands or Hadoop FS package which are used to just read the data. Now it requires some data processing. It requires some data filtering, which will be done for you. So it will create your map and reduce word. It will run those things and will produce you the data which you are requesting for. So when I'm just saying select star from stocks, their symbol is equals to REL. So it will just produce the records which are related to REL. And if I say drop table, now what was the table name? Stocks. The table is dropped, but let's go back to the UI. Oh, sorry, yeah, UI. And if I say over here, stocks folder is there, file is there. So only the metadata which is deleted for us. So I'll go back and create this table in a minute because this table would be used a lot in our program. So just give me a minute. I'll quickly create this. I will be using it again and again because this is a beautiful table. Okay, so let me go back to the PPT. Okay, let me create another internal table and then let's try to play with this. So don't worry about the structure which I'm using, but keep on remembering these kind of syntaxes. There's a lot of syntaxes how we can play with the data. So I can't cover each and every of those things in my PPTs, but I'll be using different syntaxes as per the convenience what I'm talking about, and you can just look into these syntaxes. So what I'm saying is create table new internal as select star from stocks. So here I am just creating a table called new internal table, and this table will be created as an output of the select query, and the output of the select query I hope everyone understands. So this will practically create a new table and a new folder by this new underscore internal will be created, and inside this folder there will be 1 or 2 files based on the number of reducers which have ran for us, and those files would be having the data kind of similar to what I've shown you in the query, but by now that data would be separated by the default separators or delimiters of Hive. So this is created for us, and if we can see this, let me show, go back to the UI and new internal, see new folder is created, and there's a data file and only one reducer, and there's a data. And if I say drop this table, this folder would be dropped for me. So I'll go back to the UI again, drop table and your table name, that is new internal, and that folder is gone. So new internal is not wanted, gave an error. So I'll just remove this new internal and that folder is gone. Any questions? Anything over here before I move ahead? Okay. So create an external table if not exists. So these are different ways to write the same syntax, but there's a lot of different things which are available for us. So create external table if not exist. I can give the table name and like I'm creating a table like this, and I'm saying this external table will be loading the data from here. Okay. Anyone who does not understand partitioning? And what is the beauty of partitioning? If you are really working on big data and if you are really playing with the big data, 70 to 80% of the cases or times you would be working on the Hive only. And when you are working on the Hive and you are really working on the bigger files or big data, 99.9% you would be using partition on a table. And if you don't understand partition, just ping me right away. I'll explain in detail, but otherwise I'll just assume what is the beauty of partitioning, why partitioning is used, and I'll tell you how partitioning is done in Hive. Okay, I'm just assuming everyone understands partitioning. Okay, so when you have to partition your table or partition your data, as I keep on saying you at the back, as a file, as a table is pointing to a directory, partition will always be pointing to a directory only, and by default the partition names are the same. No, okay, before that. So here what I'm saying is this is a table which I've created, employees, which has all those fields which we are discussing till now, but this table is partitioned by country and the state. So all the data related to a particular country and the corresponding state, so all the data for Canada state AB would be going inside the directory called employees is the directory of this table. And there are separate directories which are created inside employee. So for country CA, that the directory which we created would be something like country is equals to CA. And inside CA there are a lot of directories which are created for each state of Canada. And similarly, there is a directory called created inside employees, which is country equals to US, that is for US country. And inside US, there are different directories created for each state, and so on. So this is how is the default structure of partitions in the Hive look like. And so inside employees, there are directories, and the table is pointing to this employee directory. So there could be a number of directories inside your parent table folder, and so it's not mandatory to have it something like this country is equals to CA. We could have CA also, but practically I would suggest you to use it something like this, because when we are running the queries, when we are running the where kind of clauses and different things, you have to change a lot of things while you are running the queries, while you have to change a lot of things at a lot of places. And practically I will request you, if you are placing your data physically or externally, to have the folder structures like this. Otherwise I will create the folder structure similar to this if you are importing to the data into a table which is partitioned by your columns which you have defined in the partition by clause. So Pradeep said partitioning helps in physical distribution of the data. Right, Pradeep, that's exactly the point. So when I say I have 50 terabytes of data for my employees across the geography, practically inside what is here? I think Alaska. I don't know. Probably Alaska. I'm just assuming. So there would be just 100,000 employees over here. So only 100,000 records over here. So practically a file size inside this folder would be just 10 MB or 20 MB. So rather than searching my 100 TB file, when I say where country is equals to this and state is equals to this, I am practically searching a file of just 2200 MB or 1 GB kind of file. So Hive query becomes very fast. So practically when you are designing a system, and mostly in terms of Hive, you are getting your data daily. So this is now I'm coming to the architecture side, but that will be pretty useful to you. So practically your big data systems would be getting your data daily, or somehow you are getting the data, and your data would be coming into your system either daily, monthly, weekly kind of thing. So your tables which you will be creating on the data would be partitioned based on date, at least date, so that each day data is inside a separate directory, and that will give you a lot of benefits. The first thing is the partitioning benefit which I am talking about. Whenever you have to query the data of say 2014 December, I'll be querying only the folder inside year equals to 2014 and the month is equals to 12. So there will be 31 directories inside that folder, and I'll be just querying the 31 directories, and inside that directory there will be a file of 1 GB or something based on the data daily input data flow. But if my data is not partitioned, all the data is lying inside a single directory, in that case I am processing enormous number of data. So that gives you one thing. Secondly, when you have data partition based on your date and you are creating your workflows, so practically each day you are processing your data, which is a new data coming to the system. So it will be very easy for other technologies also to read that data, and they have to just go into the directory and read that data for data processing. So like you have a workflow which involves Spark also, which involves Hive also, which involves Scoop also. So Scoop will be putting your data into the directory name of today's date. Hive or Pig would be filtering that data. Hive will be creating you will be just loading that partition to the Hive table, and you are just ready with your new data. And your later on Hive queries would be processing the data, creating a data warehouse structure or your process or whatever you are doing with the data. So practically you would be partitioning your data daily kind of structure if you are getting the daily data daily or weekly or on a week basis. And you could be partitioning your data further inside your day's data, like for stock data, I could be partition it on stock name, I could partition it on exchange name, I could partition it on anything. And we can also bucket the data. We'll talk about the bucket concept, but when you mix the partitioning and bucket, you can precisely look at the correct file what you are looking for, and your queries will become very fast. So what I'm saying over here is select star from employees where country is equals to US, state is equals to IL. So this will explicitly tell my Hive to go inside the employees directory because my table is pointing to the employees directory. And then it will go inside the directory called country is equals to US. So it will go over here, and then it will go search for a directory called state equals to IL. And it will go somewhere over here and will just read the files inside the directory and will run the query for you. So by default, your partitioning mode is strict. I'll just show you what is strict and not strict. So if I say a query something like this and my table is partitioned, it will give me an error and say the partitions are not selected in your where clause. So by default, Hive mode is strict to set your partition in your where clause, and to disable the partitioning strictness, you can just change this parameter or change this property called hive.maplet.mode to non-strict, and you can search not partition table also without giving partitions. So in this case, it will go inside each and every folder of your employees directory and will read each and every file inside each and every folder and will print the output for you on the screen. I'll just show you how the partitioning tables look like, how these things look like. But any questions over here? Okay, I can look into the partitions of a table by just saying show partitions and table name. So this will show all the partitions of this table employees. So partitions employees, partition equals to country equals to US. So this will show only the partitions inside this partition. So this US is the top level partitions. So if you remember here, I created two partitions. The first partition is the top level partition. Second partition is your child partition of this partition. Okay, partitioning external tables. So before that, let's look into the table and then come over here. So let me go back to the Hive console. And so quit is the quit Hive console. So here I have the SQL queries also, and to run a file that has SQL queries, I have to just Hive -f and the file name and press enter. So that will give this file to the Hive client, and Hive client will run all the commands in this file. But before that, let's look what is inside this file. So we just looked into the internal table. Like I just showed you all these things, but let me just. So we have just seen this created a table like. We have also seen probably this also. Insert into, yeah, we have just seen it. Now let's So here what I am doing is I am creating a table, stocks partition, and I am saying it's partitioned by trade date. So if you can see the trade date column, I've removed it from the column's name. I've just given it the partition name. So my column name can be, so my table would be partitioned based on trade date. So each trade day data would be coming into the corresponding trade date folder, and the rows are terminated by comma. So let's run this command. Hive minus F. So this will create your stocks partition table, and now let's load the table, load some data into this table from our stocks table. Okay, so before that, just give me a minute. So all I say, I'll just go to Hive console, or I can directly trigger Hive queries also without from the file. I can say Hive minus E and use ZP. So this is a Hive command which will go to the Hive client and will run. So select, insert into, what is the table name? Stocks partition as select star from stocks and closing it. I'm not sure as comes over here or not. It might give an error also. We'll remove the as if as is not required. I'm not sure. As is not required. Okay, so there's one more thing over here. Let me tell you which I was missing. So we have to now define the partition column name also, by which because this table in which I'm inserting the data is partition table, and so this query is returning 7 columns, but this table requires 6 columns and 1 partition column. So we have to define the partition column also. So here I have to just say the partition by, so this query would be returning 7 columns, and out of that 1 column I'm saying this table is partitioned it. So this trade name is the output of this query name, and I'm saying partition by trade name, and the rest will go into this table. So Hive minus F. So now see there are a lot of reducers which also which will be basically there's a lot of reduction work which also will happen, and I hope you now can anyone explain me what will happen in your map and reduce phase, how this everything will happen in the map and reduce phase. Here I am partitioning my data into the dates, and there will be n number of folders which will be created for all the dates which are there in my table right now. So can anyone think of what will happen in the whole MapReduce flow? So see, it has loaded all the partitions. So these were the different dates in my data. And if I go into the Hue console, so stocks partitioned, and see a separate folder for each date, and each date will have the corresponding file. And I said comma separated, so my fields are comma separated. So can anyone quickly guess what happened at the back end, what happened on the mapper side, what happened on the reducer side, how this whole data is processed and floated inside my system? Come on. So I'm just moving on to my design Pathshala database. Show tables, describe extended, stocks partition. So see, it gave me the trade name as the partition date, and if I say show PRTATU partition, and so it shows me all the partitions of this table. Anything? Any questions over there? So we have just looked into what was there in the PPT also for the next slide, I think probably. So partition external table, that is what I'm saying you are, and if you edit, so say if your data is coming daily in your table and you are by default managing somehow so that your data for a particular date is going to a particular directory, and if your table is partition or date, all you have to do is just alter your table, add a partition, they give the partition name, which is the new folder which you have created inside the table folder, and the corresponding location, and Hive will load that partition in your metadata, and next time when you query that will be available in your query. So all you have to do is, you have to run something like this. So this is what I've shown right now, describe extended, and this shows me the table, and show partition showed me all the partitions of the table. So we'll look into deserialization in some time. Let's take a break of 10 minutes and we'll be back by 10:30 my watch. We'll be back around 10:40. Any questions? Anyone has, today everyone is very quiet. You just unmute everyone before going to the break. Anyone has any questions or anything? Anyone want to speak? I'm just unmuting everyone.
In that example, I didn't quite follow the trade date, how it understands that the trade date. I mean, when you say partition by trade date, how would it know what is trade date?
How would it know what is trade date? Okay.
Because it's not defined as a column.
Okay. Yeah, just a minute.
So it's physically. So how would it know?
Okay. So what is the query which I ran was, where's it gone? There's the query which I ran, right?
Yeah.
Okay, so what I'm doing is I'm selecting from this table, and the output of this table is being inserted into this table. Okay, that is fair enough. So when I'm saying select star from this table, let's look into this table. Describe this table. So this table has all these columns, including trade date. So what I'm saying is output of this table, where's that query gone? Where is that gone? So output of this table is input of this thing, and output of this table is partition based on trade date. So the trade date column of this table would be used as a partition for this table, and rest all will be used as an insert to this table. Make sense?
Okay, but in this case of an insert, when you are picking up from another source, it might make sense. But when you are saying create table and then giving partition, whatever partition column, in that case, how would it make sense? Let's say you are directly reading from a file, you're just specifying the metadata.
Okay.
And you are saying create table, stock partition. You give all the column names and then you say partition by trade date. In that case, how would it be?
So in that case, as I was saying you, by default it assumes the column name equals to the value of the column name is your name of the directory. So if you look over here, So if you look over here, all the directories are by this name nomenclature. You can change it definitely, but I'll not. I'll request you not to change that because you will face a lot of queries, problems while running your queries. Then you have to resolve them one by one. But you can practically change that. I can change it right away, and then also I can load it. All I have to say is this partition is pointing to this directory, this partition is pointing to this directory. So all these partitions are now, when I say trade date equals to this, it will go into this directory only. That is 2014 10th of 01.
Okay.
When I create external table also or this directory, let's say I create external table now pointing to this directory. So 1 minute. Well, give me a minute. What was the table name? Stocks partition. So I'm just looking at the command to create this table. So I can just say show create table, and this will give me the command. So I'll create another table, create table, stocks partition 1. And Pawan, I'll just come to it, give me a minute. And all the columns and partition by trade date and rows delimited by this, and location is equals to this. That's all. Let's say select. I'm now 2.2 tables are pointing to the same file structure. Hive does not worry about. Hive just maintain the metadata. So when I'm talking about this metadata, it will look into this partition. Also, when I talk about this metadata, it will also again look into the same partition. So select star from partitioned 1 table. Nothing is selected. I have just created a table. I have not told Hive that there are directories which have data, and I have not loaded those partitions. Nothing is selected over here. But when I alter the table the way I have told you in the command previously, alter table, add partition. So if I add one partition, it will load that partition into the metadata of this one table which I have created right now, and that partition will be read by the Hive when I say select star. Make sense? But when another table is same pointing to that folder structure, that can read all the data, and that's the reason, because all the partition metadata is also loaded into that metadata of the table. Vikram says okay. Pawan has a question. Miraj, can you quickly brief what happens at the back end when you run this? So Pawan, are you talking about the question which I was asking, or just a generic question what happening when I'm running the commands? Okay, so when I say what happened at when I ran this query, that was my insert into table so and so and select star from table so and so. So practically the data was loaded. So your mapper would be created as for the insert command. For the select star, I am practically reading all the data from the table, so there is no mapper reducer required. So your mapper input would be the select star from table stocks. And on the mapper phase, my key and value pair would be created based on your partitions, and a particular partition data would be intended for a reducer. If there is one reducer, everything else will go to a single reducer. Otherwise, it can go to different reducers. Over here, different files are required. So practically, there would be going to a different reducer, and the reducer side, the rest of the data would be produced as an output into a file structure. Make sense, Pawan? Sweet.
Can you repeat what you just said? I'm sorry. Hello?
Yeah.
Dheeraj, can you just repeat what you just said?
Okay, what I just said, I'll print it on the screen. Just a minute.
Yeah, thanks.
Just give me a minute. Where's that query gone? I'm just looking for that query again on this. Okay. So what I'm saying, explain plan similar to your Oracle word. What is that? Explain. 1 minute. Explain. I think it's plan only. Just give me a minute. I'm bad at remembering the commands. It's probably explain only. I think explain or explain plan. Just give me a minute. I'm just cross-checking the syntax of explain. I think it's probably explain. It's explain only. Okay, it's not plan. It's just explain only. So explain and okay. So set. So this is what I was saying over there. So see, this happened at the back end. These are 6 stages which are created for you. So first stage is the root stage. In the root stage, it read the data from the table. In the second stage was just stage 7. Depends on the stage 1. Consists of, so in the stage 7, the files are moved to a temporary location. Then in your stage 4, oh sorry, that was stage 6 we were talking about. Stage 7 is there. Stage 7 is a conditional operator. Stage 4 was your, let me just read this execution plan. I'll explain you in a minute. But what I was saying is your data is read. Your data is partitioned based on your trade date, and that is distributed to your reducer, and reducer will produce that outputs. I'll just show you over here also in the execution plan. Just give me a minute. Let me just to see where that is there for us. So map tree, your tree is created. Your data is trade date from 6.5. I don't want to go in these complexities in the class, so it takes time. It takes half an hour, 1 hour to understand all these execution plan when you're running a big query. I can't see over here, but practically at the back end, reducer will get a data for each trade date, and that would be produced as an output into your file system. I'll read this in the break time and show you. And at the file structure side, you would get all the folders, so your reducer will create these files. So all these files are inside this folder, will be created for you, and your data is distributed based on your trade date. So that is what I was saying, and that is somehow explained in that execution plan, but I was not able to read that properly. Explain. I think there's an option for detailed or extended also. Yeah, there's an option of extended also. So here I would be able to see all these things. Too big plan. This is the whole plan. Somewhere it will distributing it based on the trade date. I have to search for that. Control A. So Here partition column is trade date, number of partitions is equals to 10 based on my input data. It has find out number of partitions. Now for each partition trade date, this your operator would run, and then your data is divided. Also partition column trade date would be created, and your data is divided into your different folders. This is a big execution plan. I can't, indeed I also have to read it. It will take me half an hour, 1 hour to understand all the execution plan, but the backend something like this will happen. We can look at furthermore details of the execution plan. If you want, we'll talk about those things later on. But this is how you can look also what happens at the back end, practically what Hive has done. Otherwise, you don't understand the MapReduce flow. Pradeep, anything other than this?
No, this is good. So just at a high level, because I missed the introduction, just at a high level, anytime we are doing a map reduce, anytime we are doing a map reduce on some data that we want to analyze, we will always have to store the data in one of these, in some tables that we create? I mean, is that how it is always done, or does it depend on a case by case basis?
No, case by case basis. That's so now you understand the MapReduce part. Now you're looking into the Hive part. So now you can understand what you were able to do in the MapReduce phase. You can easily achieve that by writing a single command line query. So it will depend on you what technology you want to use, but your data would be in your SDFS world, or you can import the data also. We'll look into this scoop part. So once you have the data in your SDFS, that's all your wish how you want to process the data, and that will also depend on the kind of data which you are processing. Now whether it's structured, unstructured, semi-structured kind of this thing, and so if it has a kind of semi-structured data or structured data, Hive is the best candidate. If it's a kind of totally unstructured data, then also you can read it with the Hive, but Pig is a better candidate in that case. So it will again depend on the kind of data which you are using, going to process and things like that. But yeah, you have to get the data somehow in your SDFS world to do the processing.
Okay, so you're saying if it is somewhat really structured data, then using Hive would be a much better idea.
Yeah, because in that case it's just structured data. You're just creating a Hive. Basically, you are creating a metadata on top of that data. You are creating a table. So practically, you are just creating a metadata on top of that data. That metadata is stored in your H catalog. So when you are running some query with the help of metadata, Hive understands what kind of data you are trying to process and creates the MapReduce code for you, and will run that MapReduce code for you and produce the output at the desired location of your query.
Okay, thanks.
Okay, and I have one more question on the chat window. So if the Hive, the Vignesh has a question. So if Hive table is not storing any data, any query on Hive table will execute full MapReduce? Yes, Vignesh, if you remember in my first slide in the first session, I had shown you one chart where there was a vertical line and there was almost horizontal, not like horizontal, but a kind of inclined line at 20 or 25 degrees. So that's and that both the lines were intersecting at some gigabytes. So that was the x-axis was talking about the data and y-axis was talking about the time. So if you look at the traditional databases, that was almost vertical, more than 45-degree angle, and that line was talking about if higher the data is, less the graph for to process that data for the traditional databases would be too high. But if your data is less, the time to process that data with the traditional database is very less. So that is what I was talking about. If you with the Hive, there is additional overhead work to create your MapReduce work, to go and look into the file system. At the backend, MapReduce work, all those things, yarn, application, container, bookkeeping job, all those things happens. So for a smaller data, it will create your MapReduce work, and for a smaller data, these queries will be very much slower as compared to your traditional databases. But as you look into the big data or big volumes of data, these queries will be much, much, much faster as compared to your traditional databases. So Jignesh, another question. So Hive will help some auto map reduce and simplify the way we query, just like, yes, definitely that's what I'm talking about till now, Jignesh. So at the backend, all your MapReduce code is triggered and created by the Hive. You don't have to worry. So if you look when I run some query, select from the stage. We'll do something. Select, leave it. Show tables. Select star from has to start where b symbol equals to. So just try to read the logs which are printed. Launching MapReduce job 1. It has created your jar. It is now launching a MapReduce job. Launching job 1 out of 1. So there are only one MapReduce job which is required for this whole query. If this would have been a complex query, there would have been n number of complex jobs. Let me show if something is running. Okay. I'm switching back to another kitty. So this is my cluster. There's some complex job which is running. So here you can see it will create 3 MapReduce job for us. And it has started first MapReduce job. It is running that. It will, after that, will produce another MapReduce job and things like that. So it will basically help you to create a chain of MapReduce job. Will produce all those code, and the output of those MapReduce job will be, if you are just doing a select, will be produced on your console. Otherwise, you would be practically storing it into some other table. So that will be stored in your LGMS world. Any other questions? Okay. Okay, then let's take, it's 10:45. Let's take a break, and then let's meet at 11. So just take care of watches also. Let's meet after 15 minutes, and then we'll look into some other aspects of Hive. And if time permits, I'll give you a problem statement. Otherwise, I'll give you a problem statement. Try to do it at your backend, and then we'll discuss it in tomorrow's class. So based on the time permits, we'll look into the problem statement. Otherwise, we can look into the problem statement in tomorrow's class also. I'm back. If you're back, just ping me on the chat window. Pawan says I'm back. If you are back, please ping me on the chat window. Pradeep also says I'm back. Okay, Jignesh is also back. Vikram, Zubair, Emily. Zubair is also back. I think Vikram will be back. Emily, I'm not sure. She was there in between also. Okay, I'm just assuming Vikram or Emily are back, or they will be back in some time. Okay, I'm switching back to the PPT. So I hope everyone can recall serialization and deserialization we were talking about in the MapReduce world. So serialization is the beauty by which we can write the data into the file system and read the data. So serialization and deserialization, that is the same thing I'm talking over here. So there are different surveys which are supported by Hive, and that is located in a Hive content.jar. So if data is separated or it's in some different format, we can use different survey and desurvey, serialize and deserialize to read or write the data into your SDFS world. I'll show them to you. So let's say I was talking about the sequence file, if you can recall, in the file formats. So I've covered the file formats class also, right? I have told you the different file formats available in this in the Hadoop world and the compression and all those things, right? Yes, okay. So if I want to store my data as a sequence file, or if my data is there in a sequence file, I can use the input format reader as sequence file and the output format reader as sequence file, and I can read a sequence file data very easily. We'll just look into this. We'll create a sequence file also, and we'll see that sequence file.
Neeraj?
Yeah.
Neeraj?
Yeah.
Before you go further, I'm going to ask you a question that you kind of already probably explained, but I just want you to talk through that one more time before you go into the details. So before we left for break, you were kind of saying that, okay, as a Hadoop developer, you could use Hive for doing MapReduce. Like you could start bringing in all your data into the Hadoop file system, and after you do that, you can start using Hive for your MapReduce as opposed to the previous classes where we wrote a specific simple Java class that did the MapReduce. I mean, it internally was using the Hadoop classes, but then that was a simple Java program that we wrote. That's what you are saying, right? I mean, it's not that I have to always write a Java program to do a MapReduce. I can just use the Hive editor, and just if I know what I'm doing, I can still do MapReduce of my data using Hive, correct?
Yes, and that's the reason I was keep on saying while I was explaining the MapReduce part, you don't have to worry about the Java part, because Hadoop world is not only for the Java developers. Hadoop world is for any whatsoever your background, all you have to do is understand the concept how the data is processed, and if you understand the concept, you can easily process the data by different technologies. So Hive is one of those technologies which will create your map, reduce all those complex Java code for you at the backend, and will do the data processing. So the data processing by or somehow has to in the SDFS file system has by or somehow need to be done with the map reduce only. If your data into your SDFS, until unless we are going to things like Spark, Shark kind of things. So, these kind of technologies which are there on top of your Hadoop world will basically create MapReduce those complex jars for you, Java code, and will do the processing for you. And everything is transparent to you. All you have to do is, or remember, is the syntax of these technologies.
Okay, thank you.
Sure. So here we'll quickly look into how to create a sequence, how to read a sequence file with Hive, and similarly you can read any other files. I'll quickly show you that example. And over here what I'm doing is I'm reading an Avro file. We also talk about the Avro file, and so someone also asked me a question regarding an Avro file, how those are splittable, I think in the last class. So at the backend, Avro files are also storing the data in a similar fashion. They're somehow somewhere putting header files, and which helps them to segregate each record, and that's the reason Avro files are similar splittable as compared to your other files also. And I told you I will look into that part and get back to you. So it's similar to other files also. They also maintain some kind of header structures, and which helps you to segregate the records, and that makes them splittable. And same way you can enable the record level compressions also in your Avro files. So here I'm saying use the Serde which is lying in this jar. So there's a jar which have your Serde. You don't have to create these jars. If you just Google them, you will find all these jars which have the Serdes for different kind of file structures, and you can just import those jars into your Hadoop world. And here I'm just saying the input and output file formats are my Avro file input format class and the output format. So this input and output format, I hope everyone understands now. These are the classes which will be really reading your reading your data, or basically read your, or I would say are used in your record readers to produce a key and value output to your mapper phase, or the output format to use in your record writer to produce key and value output from your reducer phase. So let's look into this before going ahead. So I'll move back to the console. So here what I'm doing is I am creating a table, a sequence file. It has only 2 columns, key and value, nothing else. And I am saying the input format as this and output format as this. And I'm inserting some data into this table, and what I'm inserting is selecting from another table. So I'm just doing a data pipelining, which you'll be doing in your Hadoop world, and processing your data one by one. So I say Hive minus F, and I'll just give this. So here I am creating this table, and then importing some data into this table. And if I have not given any location of this table, this table a new folder would be created by this name inside my database. So when I say my output format is this thing, so by default your data would be written in your sequence file format only. So practically that file will look something like Zung to me, but I can look, there's some file which is created at that folder and that does not have anything like text, but I will be able to read from that with the help of my Hive table, and or I can just say Hadoop fs minus text. That's something on chat window. Okay. So it will take some time to run. Okay, so if I go back to the UI and sequence file, see there's a file created, but it's all junk. So, but I can read the data from this table. Okay. So it will now reuse your input format. What was the table name? Sequence. So this is also one of the way to trigger a Hive query, Hive -i, without going to the Hive console. I could have gone to the Hive console also and triggered these commands. So see, all the data is printed. So this is how you can deal with different file formats also. So now you can understand the file format which I was talking about, and now you can correlate those things, which format to use when I was talking about different file formats, how to store your data and how those would make sense while you are querying your data. Now how you can correlate all those things, what to use where and what not to use where. Now you can think of all those things, also the RC formats, ORC formats, everything. And you can store your data in the similar format. It's not mandatory for you to, when you are getting your data in that format, but you in your data flow pipeline, you will be creating those kind of file structures, and those kind of file structures then could be queried by your Hive tables and processed, and your processed output could have been created and placed into another IGFS directory. So there's a whole data flow pipeline which you will be creating up to really processing your terabytes or gigabytes of data daily or once a time. So this is I was just showing you sequence file. Similarly, you can read any kind of file formats, Avro, JSON, drop table. I was just doing with every and each in all of my files before creating the table, because these tables I keep on creating and deleting in all the classes. And as I was saying you, for external table, data is not deleted, only the metadata which is deleted. So there are a lot of alter table commands. You can alter the table once the table is created, and the beauty about whole system is only the metadata is changed. Your real data is never touched whatsoever you alter or whatsoever you do. So I can alter, even if I'm altering the internal table, nothing will happen to your data, only your metadata would be altered. I can say alter table, table name, change column, HMS to hours, minutes, seconds. So the column name is changed from this name to this name and of type integer. So it's your responsibility now to make sure the data inside this column is in format of integer. It's not the responsibility of Hive. Hive is just changing the metadata, and by metadata, Hive is just using this metadata to read or write your data. So it's your responsibility to have or keep this data in this format if you are doing or altering the table. So here I've altered the column name also, the column type also. I've altered, added new comment to the table. I've altered. So I say alter other column. Here I'm moving this column after this column. So now it's my responsibility that this column data is available after this column by the default separator or whatever separator we are using in our file. Here I'm saying replacing all the columns of my table by these columns. So these are the new columns in my table, and all the previous columns are removed. So now it's all your responsibility to ensure that your data is in this format. Otherwise, I will not be able to read it, and it might give you errors while reading the data or while you are processing the data or querying the data. Alter table, I can change the file format also. I can say alter table partition set file format. So in this partition, the data is in a sequence file format. I can alter the table and set the file format. So when the data is read from this table, it will be read with the help of sequence files readers. Alter table, I can rename the table name. I can do any kind of alteration. There are a lot of alterable commands. You can Google them out also. But it's only the metadata which is changed for you. Alter table, modify format. So here I am modifying the file format to sequence file. I think it's repetition of previous command. Here I am changing the Saturday properties. So here I am using the Saturday as JSON Saturday. I am reading a table which is at the backend stored in a JSON format, and I'm changing the Saturday properties. So prop1 in the JSON is my value 1 column in my table, and prop2 in the JSON is my value 2 column in my table. So I'm changing the Saturday properties over how I am reading the data. Alter table using JSON storage, set Saturday. I'm setting new Saturday properties. Alter table, okay, clustered by bucket. This is again an important thing. So anyone understand what is bucketing in SQL word? Anyone want to tell what is bucket in SQL word? No one? What are buckets? Okay. So other than your partitioning, we can also practically segregate our data into different files. And bucket, if you remember the concept of hashing, I was talking, keep on talking in a MapReduce word. So bucketing is also going to the same thing. Based on the key on which I am bucketing my data is segregated into those buckets. And each bucket is written as a separate file into your database. So say when I was telling you previously, I have a data coming into my SDFS Word each day for say trade data. So practically I will be partitioning my data based on date, and after partitioning my data, I might be bucketing my data on stock name. So all the stocks which are sharing the same hash key would go to a same bucket or to a same file. So here I am saying stored by a symbol, that is a stock symbol, into 48 buckets. So there will be 48 buckets which will be created inside each partition if my table is partitioned. Otherwise, if the table is not partitioned, 48 buckets or 48 different files which will be created for you, and each file have a corresponding symbol only which is intended for that hash key for which this file is intended to. Make sense? I'll show you this in an example in next few minutes. But does it make sense? What is the beauty of bucketing over partitioning? And practically you will be using both of these things to segregate your data highly into different files, and while you are querying, only the corresponding files are picked up to process, and the process or your query times reduces drastically. Okay, let me show you this. I hope no questions. Okay. So here what I'm saying is I'm creating a table clustered by a symbol into 4 buckets. So four files would be created inside this cluster table folder if I'll import the data based on this cluster. So after that I'm inserting data into this table from stocks table only, but I'm clustering it onto a different symbol. So each symbol data would be inside some particular file based on the hash key of what is the hash key used, and my data will be divided into 4 files. And I'm dropping the previous table. So practically in your cluster you will be partitioning as well as bucketing, and this bucketing will make more sense when we are doing a join between 2 tables. So when we are doing a join between 2 tables, say I'm joining this table of stock with say dividends table. So when I'm saying join join my stocks table with dividend table on date and on stock. So date will only merge. Let me go back to Excel and show you over there. So say I have two tables, stocks and DIVID dividends. Stock table is partitioned on date and bucketed on your stock. So this will make sense before that. Let's look into the output of that query, and then this example will make you more sense. So it's still running. It's hopefully almost done. I'll show you an output, then we'll explain you on Excel. That will make more sense. So now I'll show you Hadoop FS. I'll go to the UI better, easiest. Bucket. What was my cluster? So see 4 files. Each file will have a separate. So this has REL. This has SBI. This has sale and bail, and for this bucket there was no data. Although the file would be created, and later on while joining these files would be used. Let me show you how this will easier your query and reduce your query time. So when I say my stocks table is partitioned on date, so there will be different partition for each and every date. Say 1/1/14, 1/2/14. and 1/3/14 and so on, and inside these partitions I have different files based on each bucket. So if say my data is bucketed on 3 buckets, so different stocks will be lying into a different bucket. So a file 1, 2, 3, this would be having say SBI, it had this as REL, it had your something BHEL, and one more I think, say IL, and similarly over here, and similarly over here. So when I join these two tables, and dividends is say just bucketed and not partition, because dividend is given only once a year kind of thing. So it does not make to partition this table, but bucket. So when I will be joining these two tables, this file would be joined only with this file. This file will only be joined with this file, and this file will only be joined with this file, and similarly for these files also. So my join is data, or the join on the data which I am doing the join is drastically divided by 3, and in that way my join will run very fast. And if I am doing only say for October month or say January month over here, only the data for the January partitions will be loaded, and only those 31 files will be joined with the corresponding files so in the dividend. So you can think of how fast my query would become, rather than a single file which have data of gigabytes or terabytes, and I'm joining that whole big file with these files and looping all these things. So this is how your partitions and buckets are really used in your productionized versions of code, and really fasten up your queries. And to fasten up further on, you will be choosing precisely the file formats and compression kind of things also to fasten up query. And also you can do optimizations on join part. Will not be doing or looking deeper into the optimization parts. But there are a lot of ways we can optimize the points and things like that. We can look into the execution parts. So any questions on this bucket thing? Yes, Vikram, I think that's a very good question you have asked. Yes, definitely. Otherwise, it will not make sense. When you are doing a join between those two tables, practically, I'll be bucketing my table based on those symbols or based on those columns which I'll be using in my join clause. Otherwise, bucketing will not make sense. So practically, both the tables would be bucketed on the same column. So Vikram had asked a question, and that really that question should have came from someone of you. I missed to tell that part. So bucketing will only make sense when you will be using that column in the joins, and partitioning will make sense when you are using that column in your where clause. So there are two things I'm talking about: is the where clause and the joins. So when we are joining two tables and if my data is bucketed, I am just querying or I am joining smaller files. And when I'm saying a where, I'm just looking into a particular folder. So my files are divided into folders. So I'm just looking into the smaller files. So, okay. So we can also archive the partitions when all we have to do is say archive and the partition name that will archive the partition. Practically archiving a partition in the Hadoop world will create a HAR file that is called Hadoop archive file. And this file will not practically reduce the size of the data, but if there are say 10 different or 15 files in this partition, it will create a single file with the extension .har. And I hope you understand what is the beauty of that thing. Rather than 5 small files, I've created one big file, and that reduces the load of your name node, nothing else. So the files which I am not using or the partition which are older, I can archive them with the help of archive partition command. We can also enable or drop the partitions. So enable not drop means when I can't drop this partition now. I have enabled not drop on this partitions. If someone wants to try to drop this partition, that he will get an error until I say enable drop. And enable offline means this partition is there in the SDFS word but is offline. So when I'll be querying select star from table so and so, this partition data will not be selected. So this is again a new beauty of partitioning. So as your data becomes old, say at a time I'll be just looking into 3 months data. So I'll be offlining my partitions older than 3 months, and this is how my queries will be keep on running. And if later on I have to look into those data, I can just enable those partitions which are offline. I can just make that online and just disable the offline word over here, and I can look into the data. So my data is always there. I just played with my metadata, and my users are just querying or firing the same commands which they were firing previously. So at a time they are just looking into last 3 months data. Loading the data. So I think if you remember, this is the command which I ran in my first query, load the data to do a word count. So load data local in path, load data local, and one is load data without local. So there are two things over here. One is called load data local and one is called load data without anything local. And override into, I'll talk about the override thing, but before that just look into this load data command. So load data local copies the local data to the final location in the distributed file system, while load data in path without local move the data from one given SDFS location to the final location. Local means it will copy your local data that is in your Unix world on your Hive client, wherever you are running the Hive query on that Unix machine, it will the local data on your Linux machine will be copied to your SDFS word, and a table what I'm doing with the copy is this part of the command. I'll talk about this. But load data without local will look into that data into your SDFS word and will try to copy that data from SDFS word to the destination where the file is there or whatsoever I have written after this command. So here I'm saying overwrite into table employees partition so and so. So it will overwrite all the data inside this employees table and inside this partition with this data whatsoever is this at this location. So this is how I can copy the data also, but practically as I was showing you in the previous commands, you are creating your data on your SDFS word. Oh, sorry, you are creating your tables on your SDFS word where the data is already lying, and that is what you will be practically doing. But this is also this kind of things you will also be using when in your whole data life cycle. You will be copying data from one location to another. You might be overwriting your previous data. So overwrite into will overwrite the data. If I don't say overwrite, if I say insert into, will basically append the data into this partition. Other than override, if I use insert into, then that would have inserted or basically appended the data into this partition. This file will also be appended over here. But if I say override, this whole the data inside this partition will be deleted, and this data would come inside this partition. And local will copy the data from local. Without local, will copy the data from SDFS to the location of this partition in this query. So in the first query, I just said local load data and some into the table from a particular location. So over there, I'm just loading the data into the table. Otherwise, I would have created an external table on that location where my file was. So instead of that 3-line query to a word count, I could have done it in 2 lines only. So what I was talking about, the overwrite keyword is described over here. Will overwrite your data. Okay, so there are 2 kind of partitions. Till now, when I was storing the data, I was explicitly saying to which partition my data is going, but I don't have to do this as I ran in the previous query on the Hive console. Here I'm just saying country and state. So this is an example of dynamic partitioning. Hive at the runtime will find out to which partition this data need to go, and will output of this query would be segregated into those partitions. But I will show you in the partition command, and this is called dynamic partitioning in Hive basically. Otherwise, I could have set country is equals to US. So in that case, irrespective of the country chosen from this command, the data would go to the country is equals to US directory only. So that is called static partitioning. So if I'm using a static partitioning like this, I know that the data output of this command is explicitly intended for that partition. Otherwise, I can use a dynamic partitioning. So this is an example of mix of dynamic and static partitioning. Probably you might be knowing the country for which that you have selected the data, but you don't know the state. So I'm using a static partition as well as dynamic partition state. Okay, so by default your dynamic partitions are disabled. You have to enable them. While you run this query, you will get an error. So you have to again do a set dynamic partition to true to enable your set dynamic partition, and to while you are querying that data, that is again in a strict mode. You have to make it non-strict to query the partition dynamically. And there are other parameters also for the dynamic partition. I just copied it over here for your reference. So here I'm selecting data from this table and writing it directly to a particular LGFS directory rather than importing it to a table. So there are n number of flavors of these commands. You think of, you would be able to do that thing by somehow in the Hive tables, or by somehow using the Hive queries. There are n number of ways. So this is an example of nested select. So these are different syntaxes. Wherever you don't understand a syntax, do let me know, I'll explain you. But I'm just assuming every one of you knows the SQL word, and these are just different kind of flavors of MySQL queries. So here I'm saying for nested select, so I've created an inner table. Where is that inner table? So this is the inner table which is created. So this whole thing is an inner table referenced by E, and I am saying select E dot this where E dot salary is greater than 70,000. So my some employees printed. So I can create inner table or nested tables, but how we can create it in a MySQL Word. It's similar to that. I'm creating this inner table. Case statements as we do in our MySQL Word. Case when this, when this, when this, when this, and this. So when the salary is less than 50,000, low will be printed. When the salary is greater than 50,000, less than 70,000, middle will be printed. And when the salary is really greater than $70,000, high would be printed as very high. Group by, I hope everyone understand group by and having clause. Wherever you don't understand the part, please ping me. I am just assuming that these are pretty simple MySQL kind of queries, and this is this all every one of you knows these things. So group by anything, group by having, so it will print you only those records which are having average price greater than 50. So only those things would be printed which are having average price greater than 50. Joins you can for your reference, the version on which you are running right now, the Hive queries, that is Hive 0.12, there you can't do like your MySQL Word from table A comma B where A dot ID is equals to B dot ID. In version 1.2 you can use the joins like this only. You can't say from A comma B. You have to use joins like this only, or you can use all the type of joins, inner joins, left outer join, right outer join, full join. But you have to use a join to join the tables. But in Hive 0.13, that is the latest version of OVA. That OVA file I'll share with you, or I'll share the link. You can download that 5 GB OVA file that has the latest version of Hortonworks that has Hive 0.13, and there you can say from table A comma B where A.id equals to B.id. But in this version, on which you are running your queries right now, or you will be running your queries right now, you have to use joins like this only. So here what I'm saying is, so here what I'm saying is select so and so from stocks table, join stock, B on A.year month date, B.year month date, and where symbol is equals to so and so and symbol equals to so and so. So few of the optimization things I'm talking about, I'm not talking about the detailed optimization. That requires a detailed session that is not covered in this session. But let me talk you few of the things which you can think of while writing a queries and that really optimizes the queries. So while joining 3 or more tables, if on every on clause we are using the same join key, a single MapReduce job would be triggered. So when I say join table A and B on A.year month date, B.year month date, and join C on A.year month date equals C.year month date, in that case a single mapper can do all your work. So a single MapReduce flow would be created. If the join would have been on different keys, then there would be a different MapReduce course would be created. So if possible, if possible in your query, if you use the same on clause, you can reduce your whole MapReduce flow. And when I'm joining it, rather than using the big table first, use a small table first, and that will make your table faster. And the reason behind that is Hive assume that the first table which you are loading is a small table. There's a way I can tell Hive also, but assume that the first table is smaller and the next table is bigger, so it will keep your smaller table in memory and will call your bigger table row by row for each row and will process the result. So when I have to do a join between two tables, practically one table has to be looped, and another table records has to be looked into into that loop to find out to basically do the joining. So if there are 3 records in my small table and there are 10 records in my big table, so for each record in this table I'll be using this cache and merging this. So for the first record the 3 records will be mapped, for the second record again the 3 records will be looped up, for the third record again the 3 records will be moved up till the 10 records are moved up, and only the joining conditions will be produced. So it will try to cache your smaller table and produce and do your MapReduce loop. So I've assumed the last table is the largest in the query, or we can give the hint like streamable. So it's similar to a hint which you give in a MySQL Word. So it's almost similar to all your what you can do in a SQL Word. There are syntaxes. If you think of, just Google it, you will be able to find the syntax. So this basically hints the Hive that this table can be streamed, and so Hive will try to keep it in memory and stream this table and to the price table. Sorry, price is the column name, to the table B, that is dividends. Anyone want me to explain what is left outer, right outer join? Anyone want me to explain what is left, right outer joins? Okay. So we can have this left outer joins, we can have right outer joins. I hope everyone understands all these things. These are pretty basic things. I'm just assuming up. If you want me to explain, please ping me. No. One says no. Okay. Practically, don't do this thing in your Hive Word or in your production clusters. Emily says good. So Emily, I'm not sure. Good by means you said good for not to understand or not to explain or to explain. Sorry for that. But I'm assuming you said not to explain. Okay, sure. So anyhow, Emily don't want to hear about those things. Emily belongs to the company which creates all these things. So Emily would be expert of this thing. So practically, I would suggest you not to create indexes on a Hive query. This will not beneficial for you if you have properly partitioned and clustered your data. This is my personal experience which I'm talking about. If practically you have partitioned and bucketed your data, indexes will not give those kind of performance benefit as your bucket and partitioning gives. But there are ways to create indexes. So this is a table on which I am creating index. So I am creating index using index type. So this over here, this Java file contains all the logic how to create an index. So I am using this with default rebuild. That means I will build it later on, and the index properties on the table, and this is the index name, and this is a column on which the table would be indexed. But practically never use those indexes in Hive. I did not want any benefit. There is an overhead to maintain this index, and the benefit of index is lesser as compared to overhead of maintaining the indexes. Okay, that's all from this thing. On the Hive side, it's very much similar to a MySQL Word, and there's nothing great. Does anyone have any questions before I talk about and give you some problem statement? Let's try that. We have 10-15 minutes. You try to create a table and then do a merging kind of thing. I'll share a problem statement. If anyone has any questions before I share the problem statement with the people.
Okay, a question on the load data part you were explaining earlier.
Yeah.
Does it mean that that input file is actually getting split? If you are
no, it's split. No, not. Sorry, can you please
Sorry,
elaborate?
if you are using the partitioning and bucketing, let's say, then is it really effectively getting split?
Yeah, practically we are splitting the file into n number of files, and when we are really querying the data on that table, we are just looking into the smaller part of that file.
Okay.
So just give a minute. I'm sharing the file on the Google Drive. You can download it, and I'll open it also for you. Uh, so I have your email IDs probably. 1 minute. So Jignesh says is good. I'll drop off. No worries, Jignesh. I'll just discuss the problem statement. You can try it out if you want to try it out. And if you face problems, we can discuss that in the next task also. So I'm just opening the email IDs of yours so that I can share that file with you people. So I have it. I'm just dropping you emails on your corresponding Gmails. Or the corresponding email IDs which I have. So I'll just send you an email and share the file. I'll show that what I've shared with you, and if you want to try now, you can go ahead. Otherwise, you can try it later on, and we can discuss it whatsoever way you wish. So I'm just sharing the screen. So I hope everyone can see my screen. So here I've shared two CSV files. One has a stored sales data and one has the data related to the orders which are returned from a store. So I'll open these files and show you in just a minute. So the sales data looks something like this. It has your order ID, it has order dates, total sales, the customer name, as well as different things about the data, on the order data on which the sale is done and the date on which sale was done. And the other file has the order ID and the status returned. So on the orders which are returned are basically in this file. So in the problem statement, what I want is first you people create a table on these two files. So first you have to put these files into your SDFS Word. Beware, you have to remove these headers from these files because your practical data will not be having the headers. So sometimes you might be getting data which you have to first process or cleanse before storing it or before creating a table. So there's a manual step which you are doing. You could automate all these things in your workflow. But over here, just remove this header file before importing this data into your Hive Word. And once the table is created, these two tables are created. Then we have a problem statement which talks about So just opening, give me a minute. Okay, so it's here. So I hope you can see my screen. There's a PDF which I've opened, I have exercise.pdf. So here is a pretty simple exercise which I've shared with you people. So you have to load those files, create tables on each of these files. It's your wish to create an external table, internal table, how you load the data. It's your wish. After that, and before that, what I'm saying is these files are comma separated, so you have to use the comma delimiter and don't forget to remove the headers. And once you are done, you have to merge these files and produce an output for those customers who are returning the orders to me in a format, and that output would be descending by the number of return orders by a customer. And if two customers have the same number of return orders, the output will be ascending in the name of the customer. Very simple query, but this will give you understanding how the data flow happens, how to create the tables, how to look into the data, and how to join the table. So this will give you a flavor of whatsoever we discussed in the today's class. And after loading the table, it's your wish if you want to partition or bucket the data and to optimize the data, optimize your query joins. So do you want to try it now, or you want to try it later on at the home and then we discuss it in tomorrow's class? Whatsoever way you wish, we can do that. Just let me know the way you wish you want to do it. Are you trying it now, or so what do you say? Emily, Pradeep, Vikram, Zubair, Pawan? Pawan says I'll try later. Okay. Vikram, not trying now. Okay. Okay, the way we will try later. Okay, so everyone want to try it later. Okay, you can try it later on, and we can discuss it in tomorrow's class. If you are facing any issues, or if you want to try it in tomorrow's class, you can try it. That's the way you want to go. Sure. Then any questions before we wind up for the day then? I hope you understand what is the uses of Hive, where you'll be using your Hive, and once you're getting in the data into a cluster, how you'll be using Hive queries to process the results. And before winding up, let me show you one more thing which came to my mind right away. So over here, if you remember, there's something called Hive Edge catalog. So this is the real person who stores all this metadata for us, where the real metadata is stored. So it's just opening up. So I can browse all my tables, which I was talking about, all the databases from here directly. It's a little slow. It's opening up. What happened? It became very slow. My PC suddenly became slow. Okay, So see all the databases by default, there's a database called default I was showing you as I was talking previously. So if you don't define the database or if you don't use the database, by default all the tables will be created in your default database. So these are different databases. It's extremely slow now. I don't know. So I was using DP. All the tables inside DP. I can browse the data directly from here on the DP. I can just say browse data over here. So if you look into the latest version of Hadoop, other than browsing the data, they have a pretty beautiful way. You can look into the data. Basically, there are different charts which you can just click on, like in Excel. You can just click on the chart option and that will create a chart on your data which is lying at the backend for you and will display it on the UI. So here at the backend, it will just run a MapReduce query and will get the data for me. And from this console, I can directly trigger the Hive queries rather than going to that black box. If black box is scary to you, you can go to this Hive UI and you can run the queries from here also. Okay, then I'll share this PPT with you, and if you have any questions, you can ask me right away. Otherwise, I'll assume no questions and then we can write off. Okay, then looks like no questions. Then have a good day, guys. So let's meet tomorrow, and tomorrow we'll talk about PIC. And then sure. Bye bye. Thank you. Thanks for your time. I hope you got the things what we are discussing about. Bye bye. Have a nice day.